Walter Longo spent years at the University of Southern California running some of the most extensive fasting research conducted in humans and animal models. His team fasted subjects and mice for periods ranging from 2 days to 5 days, then carefully measured what the body was doing at each stage. What they found at the 48-hour mark specifically was not what they expected to find, not weight loss data, not metabolic markers. What they found was strategic. The body's immune system was doing something that looked, at first glance, like decline, but that turned out to be the preparation for something far more significant. At the 48-hour mark of a fast, white blood cell counts drop substantially. In some of the research, up to 30 to 50% of circulating white blood cells decline. In any other context, this would be alarming. In the context of extended fasting, the research revealed it to be deliberate, the body selectively clearing old, damaged, and inefficient immune cells to conserve energy, and in doing so, signaling the bone marrow to prepare something new. What happens next is what changed how Longo thought about the immune system entirely, and it does not happen during the fast. It happens the moment you eat again. Think of the body at 48 hours of fasting as an international airport that has temporarily closed all incoming and outgoing flights for deep maintenance. When the airport is continuously running, flights arriving and departing, terminals full, baggage systems active, the maintenance crews can only access what is not in use. They patch the visible problems. They work around the active equipment. The deep structural maintenance, the runway resurfacing, the complete systems overhaul that requires the airport to stop. At 48 hours, the airport has stopped. The runways are empty. The terminals are dark. The maintenance crews have full access to every system, including the systems that were always in use and never had full inspection time before. Here are the 5 most significant things happening in the body during those 48 hours. Number 1, hunger paradoxically decreases after hour 24. This is the most counterintuitive aspect of the 48-hour fast, and the one most people who have never done one find hardest to believe. Ghrelin, the primary hunger hormone, does not rise continuously during fasting. It spikes in waves that align with your normal meal times. If you usually eat at 8 in the morning, noon, and 6 in the evening, you will feel hunger surges at those times. Between surges, ghrelin falls. During the first 24 hours, these waves are intense because the body is still expecting food at the usual intervals. The second day is physiologically more difficult than most people anticipate, specifically because of these timed surges. By the 36 to 48-hour window, something shifts. The body has now been in full ketosis for 12 to 24 hours. Ketone bodies, particularly beta-hydroxybutyrate, have an appetite-suppressing effect. Ghrelin regulation adapts to the reality that no food is coming. The surges weaken. Many people report that the second day of a multi-day fast is harder than the third, precisely because the ghrelin adaptation that begins in hour 36 has not yet fully taken hold in hour 24. Research and self-reports from extended fasting studies consistently describe this phenomenon. The hunger that felt most acute at hour 18 to 24 is less acute at hour 42 to 48. The airport's food service terminals have closed, and the staff has accepted the closure. The demand for service has diminished accordingly. Number 2, hour 48 is peak autophagy. Research published in Science Insights synthesizing the current understanding of cellular regeneration during fasting places the 48-hour mark as the point where autophagy and cellular repair are at their most active across multiple tissue types. The mechanism, mTOR suppression, deepens continuously from hour 12 onward. At 48 hours, mTOR has been suppressed to its minimum measurable level for an extended period. AMPK has been elevated throughout. The autophagosome formation rate, the creation of the cellular packages that capture and process damaged material, is at its highest. The lysosomal fusion rate, where captured material is degraded and recycled, is at its highest. Animal studies and the limited human research that exists consistently support the 24 to 48-hour window as the range where autophagy reaches levels associated with meaningful cellular recycling across diverse tissues, not the initiation of autophagy, which begins around hour 12 to 16, the peak of it. At hour 48, every major organ system, the liver, the brain, the skeletal muscle, the cardiac tissue, is running its cleanup system at maximum capacity simultaneously. The maintenance crews have been in the airport for 36 hours and have had full access the entire time. Number 3, white blood cells decline strategically and stem cells prepare. This is the finding from Longo's research at USC that most discussions of 48-hour fasting do not include. During the fast, circulating white blood cell counts begin declining at the 48-hour mark. The body is selectively removing older immune cells, those showing signs of damage or dysfunction, those that are less efficient, those consuming energy without proportional benefit. This is not immune suppression in the clinical sense. It is targeted clearance. The biological mechanism involves the drop in IGF-1, insulin-like growth factor 1, that extended fasting produces. Low IGF-1 signals bone marrow hematopoietic stem cells to shift from dormant states into a state of preparation. These are the stem cells that generate all blood cell types, including the immune cells. The immune cells that were cleared during the fast created a signal and a vacancy. The stem cells in the bone marrow have received the signal. They are ready. But what happens next requires something the fast cannot provide: nutrition. Number 4, insulin reaches its absolute minimum. At 48 hours, insulin levels are at their lowest measurable point in the entire fasting window. The pancreas has not been required to respond to incoming glucose for 2 full days. The insulin sensitivity of cells throughout the body has been resetting during this window. Cells that were responding slowly to insulin signals because of chronic overexposure have had the exposure removed for long enough to begin restoring normal sensitivity. Research on the impact of 48-hour fasting on glycemic control shows that this window represents a metabolic rest for the pancreas, unlike any achievable through intermittent fasting protocols. The continuous insulin signaling that contributes to insulin resistance over years requires a minimum of 12 to 14 hours of zero stimulation to begin reversing. At 48 hours, that reversal has been in progress for 34 to 36 hours. Visceral fat, the metabolically active fat stored around the organs, responds specifically to low insulin conditions. With insulin at its minimum and ketone production at its peak, the body has been drawing primarily from visceral fat stores throughout the second day, not subcutaneous fat, visceral fat, which has a higher density of the receptors that respond to the low insulin, high growth hormone fasting state. Number 5, how you break the fast determines whether 48 hours mattered. This is the finding that connects everything that happened during the fast to what happens after it. The white blood cells that declined strategically during the fast created the conditions for bone marrow stem cell activation. But those stem cells need raw materials to produce new immune cells. The raw materials are the amino acids, micronutrients, and energy substrates that arrive with the first meal. If the first meal is high in processed food, refined carbohydrates, and inflammatory ingredients, the stem cells attempting to produce new immune cells are doing so in a hormonal environment that drives immediate fat storage and inflammatory signaling, the same environment that the 48-hour fast was working to clear. The insulin spike from a large carbohydrate-heavy refeeding meal suppresses the regenerative processes that the low IGF-1 state had initiated. If the first meal is moderate, protein-centered, low in refined carbohydrates, and consumed in a relatively small amount, the stem cells have what they need to produce fresh white blood cells in a hormonal environment that supports the regeneration rather than competing with it. The immune system that emerges from the fast and refeed cycle contains a higher proportion of newly produced immune cells than the one that entered it. The airport that just finished 48 hours of deep maintenance opens most efficiently when the first flights back are light loads that let the newly serviced systems demonstrate their improved function, not immediate full-capacity reopening that stresses every system before the maintenance work has been tested. Before the protocol, 48-hour fasting carries risks that shorter protocols do not. Electrolyte depletion, particularly sodium, potassium, and magnesium, becomes significant in the second day and requires active management. If you have diabetes, kidney or liver disease, cardiovascular conditions, a history of eating disorders, are pregnant or breastfeeding, or take ongoing medication, speak with your doctor before attempting 48 hours of fasting. Extended fasting is not appropriate for everyone and carries real risks when done without preparation or medical awareness. This content describes general physiological mechanisms and does not constitute a treatment protocol for any condition. The practical framework: 48 hours is 2 nights of sleep plus the waking hours between them. The preparation in the week before, reducing carbohydrate intake, establishing a shorter fasting window consistently, determines how difficult the second day will be. The refeeding meal, moderate, protein-centered, not a celebration feast, determines whether the immune regeneration that the fast prepared for actually occurs. If this changed how you think about what the body is doing at the 48-hour mark specifically, subscribe and leave a like. Tell me in the comments. Did you know the white blood cell decline during extended fasting was strategic rather than damaging, And has that changed how you think about the refeeding meal?